about what we're going to look at in this specific class. This is Introduction to Robotics, so we're going to look at the nuts and bolts of manipulation and mobility, a slightly more focus on manipulation. We're going to start with something that's important in robotics in general, which is just how to operate in 3D space and how to reason about where things are relative to each other in 3D space. Again, robotics is by definition the field of effecting physical change on the world. So then you need to start thinking about where things are relative to each other and how to operate in 3D space. So this first bit applies to robotics very broadly, also to other fields as well. Then we'll talk about manipulation, and in particular robot arms. We'll be doing quite a bit of mathematical modeling. How do you model? How do you analyze? How do you characterize robot arms? Then we'll do the same for mobility. How do you model mathematically? How do you characterize some typical mobility platforms? Then what we'll do is the last big chapter of the class can be thought about as an example of a robot that is reacting appropriately to an unforeseen situation, which is motion planning. So the robot, assuming that the robot has a map of the environment, but where it needs to go is not known in advance. It will receive instructions on where to go, but those instructions will come at runtime as the robot is moving through the world. So we cannot pre-program a trajectory for the robot to follow, because where it needs to go will change in ways that we cannot foresee. So then this task of the robot planning and executing a path through the environment that gets to the goal is an example of a robot operating in an unforeseen situation. And this will be the last chapter of the class. It applies equally to robot arms and to mobile robots. They both need to move through the environment to potentially goals that are unforeseen. The assignments in the class will be using a particular software framework called ROS, or the Robot Operating System. And in general, the concepts will be independent of ROS, but the assignments will give you a chance to familiarize yourselves with ROS and start programming. And really, what we cover in this class is the foundation that more intelligent robots then build upon. So this will give you the foundation to really get deep into notions of intelligence and robotics. Some of the things that are not covered in this class, we're not going to be looking at how to build robot hardware, how to design it, mechatronics aspects, embedded programming. So in a sense, really, this class focuses more on the brain than the body. The body still matters because we're going to be doing mathematical models that are very intrinsically related to what a robot physically looks like, but we're not going to be doing design or mechatronics or embedded programming. We also will not touch, except very briefly, on sensing and perception. The first two bullets here, those can usually go into a separate class on robotic design and mechatronics, whereas sensing and perception, they either go into a class dedicated exclusively to, for example, machine vision, or an advanced robotics class where really perception and planning in reacting to the perceived data are front and center. So with that, welcome to the class. Hope you enjoy it, and let's get into robotics.